Uh, Today, I will discuss about the semantic analysis. Still, there is some portion is left in the predictive parser, that is how to build the predictive parsing table. Basically, from today, I will cover both the chapter, both the topics simultaneously. That means parsing one day and remaining part of the syllabus in one day. In this way, we will proceed. We have already seen how a parser construct the parse trees in the syntax analysis phase. But actually, plain parse tree constructed in this phase is generally no use for a compiler. Just only the parse tree will not help the compiler because it does not carry any information how to evaluate the tree. Now, the productions of the context-free grammar, which makes the rules of the language but do not accommodate how to interpret them. This is basically production rules, and this is basically in the syntax analysis phase. E produces E plus T. But you just see here, actually, this above context-free production has no semantic rule associated with it, and it cannot help in making any sense of the production. Okay, that is, we will go for the semantics. What is semantics? Semantics of a language providing meaning to its constructs like tokens and the syntax structure. Semantics help interpret symbols, their types, and their relations with each other. Semantic analysis judges whether the syntax structure constructed in the source program derives any meaning or not. And that is why from the semantic analysis, actually we can go to our another module, that is syntax directed definition. That is context-free grammar plus semantic rules. Semantic rules means rules that provide what to do, equals to, this is basically known as syntax directed definition. Or sometimes it is also known as the, based on these things, if we evaluate something, then it is known as the syntax directed translation scheme, SDTS. Is it clear so far what I have told you? What is SDT? Is it
Yes,
okay?
sir.
Yeah. Just remember clearly that production rules, production, that is context-free production, with the semantic rules will give you the idea what to do, and that is known as the syntax directed definition. And after using that definition, when evaluating something, we are evaluating some results or like these things, then this is known as the syntax directed translation schemes. Here you just see int a assigns to some value should not issue an error in the lexical or syntax analysis phase, as it is lexically and structurally correct. But it should generate a semantic error as the type of the assignment defaults. Just straightforward write in this way, in double quote only simple value. Here actually in the lexical phase and the syntax analysis phase, it will not give any error. Okay. But in case of, it will produce a semantic error as the type of the assignment default. This is the integer and this is something string or like these things. And these rules are set by the grammar of the language and evaluated in the semantic analysis. That is, what is the semantic analysis does? Scope resolution, type checking, and array bound checking. We will see these things. Scope resolution. Can you tell me what is the meaning of the scope resolution?
So brackets like the
Hmm? Hello?
Yes, the scope in which the
Mm,
program will run means that brackets that we used in program kind of the execution criteria means under which the program will run, up to which the
yeah,
program
that
will
means
execute.
uh, just see. Can you remember the mm, auto variable, auto register variable, auto variable, register variable, then external variable like these things in C?
Yes, sir.
Yeah, this is the example of the scope resolution also. Basically, what is that? When you are declaring a variable, simple int a. Int a, you are declaring a variable in the procedure itself, a simple procedure. Procedure 1 or function 1. In that case, the scope of the variable is limited only on that block or on that function. That means what you're telling, that in between the curly brackets or like these things. You can use that same variable a in another function in the same program, because in that case, first a, that is a declared in the function a, has its limitation or has its scope in that function. A declared in the function 2 has its scope in that function. That is the thing. This is basically scope resolution. Next one is the type checking. Type checking means, what is that? Type checking is basically this type of, we will see this idea of the type checking, but type checking, whether technically it is correct or not. Here actually you are assigning, you are declaring the a as an integer and trying to assigning some string there, and this will be a type mismatch. Error will produce in the semantic rules, and this is done with the help of the type checking. And array bound checking, that is also this thing, that is basically we will see. This is mostly used when trying to convert array declared in the multi-dimensional phase. That is, multi-dimensional array needs to be converted into the single dimension. How it is calculated, how the values are calculated, how you are getting the address of these things. Suppose you have declared a matrix, and how you are getting the address of each of the element of the matrix, that is basically lies in the array bound checking. And also these things, that means when you are declaring an array size, in that case it is also, that means when you are declaring the array size, your semantic rules will give you the idea, that is when you are trying to access an array elements, it belongs to that size of the array or not, like these things. This is also basically array bound checking. Now, what are the semantic errors we can get? First one, as you see, type mismatch, undeclared variable, reserved identifier misuse. That means some reserved identifier. That is, you are using some keywords like these things. This is also multiple declaration of a variable in a scope. Single scope, you are declaring multiple variable declaration. That means a, you are using in a single function, you are using a as an integer, you are using a as a float. In that case, this is multiple declaration of variable in a scope. Accessing an out of the scope variable and actual and formal parameter mismatch. That means you are passing a function three formal parameters, and when you are calling the functions in the main, you are using two parameters, actual parameter. This is also for actual and formal parameter mismatch. This is all about, this is the basics semantic errors we are getting in matrix. Next one we will see attributed grammar. Attributed grammar. What is attributed grammar? Attributed grammar is a special form of a context-free grammar where some additional information, that is attributes, are appended to one or more of its non-terminals in order to provide context-sensitive information. Each attribute has well-defined domain of values such as integer, float, character, string, expressions, etc., etc. Now, attributed grammar is a medium to provide semantics to the context-free grammar, and it can help specify the syntax and semantics of a programming language. Attributed grammar, we will see, when viewed as a sparse tree, can pass value or information among the nodes of a tree. You just see, this is an example of an attributed grammar. Grammar with its meaning is there. E produces E plus T means E value plus T value will be modified E value. This is the meaning of this expression. And this is the example of an attributed grammar. You just see the right part of the CFG contains the semantic rules that specify how the grammar should be interpreted. Here the values of the non-terminals E and T are added together and the result is copied to the non-terminal E. Semantic attributes may be assigned to their values from their domain at the time of parsing and evaluated at the time of assignments or conditions. Based on the way the attributes get their values, like this example, they can be broadly divided. Based on the ways attributes get their values, they can be broadly divided into two categories. One is the synthesized attributes, another one is the inherited attributes. Is it clear so far? Everybody is understanding these things? What is
Yes,
attributed grammar? Priyabhata Naskar, are you understanding?
Yes, sir. Yes.
Okay. Every group, so every project group basically, so have you contacted your mentors, project mentors? Every group you should contact your mentor, or you must contact your mentor as early as possible.
Okay, sir.
Okay, sir.
ঈশা কি বললাম বোঝা গেল?
হ্যাঁ স্যার।
কন্টাক্ট করেছিস?
হ্যাঁ স্যার, আমরা করেছি।
Okay. Next one, synthesize attributes. These attributes get values from the attribute values of their child nodes. These attributes get values from the attribute values of their child nodes. Suppose you just see, assume the following productions. S produces A, B, C. If S is taking the value from its child nodes, that is A, B, C, then it would be a synthesized attributes, as the values of ABC are synthesized to S. Here actually just see E produces E plus T, and the parent node E is getting the value from its child node E and T. And this is an example of the synthesized attributes. Synthesized attributes never take values from their parent nodes or any sibling nodes. This is synthesized attributes. Next one is the inherited attributes. In contrast to the synthesized attributes, inherited attributes can take values from their parent and or siblings. You just see S produces A, B, C. A can get the values of S, B, and C. B can take the values from S, A, and C. C can take the values from S, A, and B. And this is the example of the inherited attribute. Although here S will get the value from A, B, C. That means when A is getting the value from S, B, and C, this is the example of the inherited attribute. But when S is getting the value from ABC, this is the example of the synthesized attributes. This is the basic difference between synthesized and inherited. And when a non-terminal is expanded to terminals as per the grammatical rule, you just see, this is expansion. E, from E we are getting these things, and reverse way when we are doing these things, this is known as the reduction. Expansion means when a non-terminal is expanded to terminals as per the grammar rules. These are things. From E, we are getting these things. That is, finally, we are getting the terminal symbols expression. ID plus ID star, it may be ID here. And reduction means the reverse way. That means here it is top to bottom approach, and reversion is the bottom up approach. These are things. Already we have seen this concept. And semantic analysis uses both these. Just a minute. What is reduction? Already we have seen this concept, but when a terminal is reduced to the corresponding non-terminal according to the grammar rules, and syntax tree are parsed top down and left to right, whenever the reduction occurs, we apply the corresponding semantic rules, and this is known as the actions. And semantic analysis basically works based on this syntax directed translation to perform the above task. And semantic analyzer receives the abstract syntax tree from the previous stage, that is syntax analysis. Now, abstract syntax tree, no rule is associated. Now, semantic analyzer attaches the attribute information with the abstract syntax tree, and which is known as the attributed abstract syntax tree. You just see here, attributes are the two values, two tuples, attribute name and corresponding the attribute values. Here you just see int value assigns to 5, that is type, followed by the integer. That is type is integer, and present value, that is 5. That means it will be integer followed by 5. And for every production, there must be a semantic rules. Now let us see an example of ACE attributed syntax directed translation. If an syntax directed translation use the only synthesized attributes, it is known as the ACE attributed syntax directed translation. And these attributes are evaluated using ACE attributed syntax directed translations that have their semantic actions written after the productions. You just see here, this is E value, this is T value, and now you are getting E, final E, that is parent of this node is getting the E value in this way. That is E value equals to E value plus T value. And here you just see attributes, attributes in ACE attributed syntax direct translations are evaluated in the bottom of parsing as the value of the parent node depends on the value of the child node. Here you just see bottom up parsing, because we are going from bottom to up, and the value of the parent nodes will get the value of the child of these nodes. This is the ACE attributed syntax directed translation. Next one is the AL attributed syntax directed translation. These form of syntax directed translation use both the synthesized and inherited attributes with restriction of not taking the values from the right siblings. Just try to remember these things. This form of AL attributed syntax directed translation, this form of syntax directed translation uses both synthesized and inherited attributes with restriction of not taking values from the right siblings. In AL attributed syntax directed translation, a non-terminal can get the values from its parent, child, and sibling nodes. You just see S produces ABC, S can take the values from the A and B and C. This is the synthesized example, but A can take the value from S only, B can take the value from S and A, because you just see AL attributed syntax directed translation, and that is why A can take only value from the S only, because S cannot, restriction that it cannot take the value from the right siblings. That is why A can only take the value from S only. B can take the value from S and A, and C can take the value from B, A, and S. And in that case, this is an example of the AL attributed grammar or AL attributed syntax directed translation scheme. And attributes in the AL attributed syntax direction translation are evaluated by the depth first and depth first, as well as the left to right parsing manner. That is why we can conclude that if a definition is the S attributed, then it is also AL attributed, as AL attributed definition encloses the S attributed definition. That means it is a superset and this is the subset. AL attributed syntax translation scheme may contain the S attributed syntax directed translation schemes also. So far, is it clear? AL attributed and S attributed.
Yes, sir.
Yes, sir.
Yes, sir.
Now, what I have seen, we will see this concept with an example also, several examples. Already we have seen what is the meaning of the syntax directed translation in the compiler design. That is, again, I am repeating these things. Parser uses a context-free grammar to validate the input string and produce output for the next phase of the compiler. Output could either be a parse tree or a abstract syntax tree. Already we have seen. Now, to interleave the semantic analysis with the syntax phase analysis phase of the compiler, we use the syntax directed translation. Just a minute. That is, you just see here. Already we have seen, that is again repeating these things. Syntax directed translation of the augmented rules to the grammar that facilitate semantic analysis, and syntax directed translations involves passing information bottom up and the top down parsing tree in the form of the attributes attached to the nodes. It is used lexical value nodes, constants, and attributes associated with the non-terminals in their definition. Let us see the newer one. You just see here. You just see another example here. This is another example. E produces E plus T or T. T produces T star F or F, and F produces integer literal. Here you just see meaning of the production rules. That is semantic rules. You just see here this one, this one, this one, this one, and this one. Here actually it is taking the integer literal value, that is, it will take the legs value. Now, based on these production rules, we will focus on evaluation of some expression. Let us see.
Sir, am I audible?
Yeah. Hello. Do you have any questions? Hello. Just see this line.
Yes, sir. Today's network is not well, sir.
Hello.
Hello.
Syntax directed arguments rules with context tree that associate number one.
Sir, इधर बहुत बारिश हुआ सर, network problem हो रहा है.
You are calling from where? You are connecting from where? You just see who are you? Who is saying these things? That problem. Who is facing this network
Sir,
issue?
he is Rahul, sir. Sir, he has network issue, sir. Rahul. Sir, CR, sir, Rahul.
Okay, Rahul. Let me continue. If you have any doubts regarding these things, you can ask me later on. Okay. Rahul, is it okay what I'm saying? Okay.
স্যার ওর নেটওয়ার্ক চলে গেছে ওই জন্য কথা
নেটওয়ার্ক
বলতে
চলে
পারছি
গেছে,
না।
ওকে বলে দিস জাস্ট ওর ডাউট হলে
আচ্ছা
আমি একটু পড়িয়ে দিও, আমাকে জিজ্ঞেস করে নেব আলাদাভাবে, ঠিক আছে?
আচ্ছা আচ্ছা বেশ।
Generalizing the STD augmented rules to a context tree that associated set of attributes to every node of the grammar. Number two, set of translation rules to every production rules using the attributes, constants, and the lexical values. Like this. Just see here. S equals to how to evaluate the semantic analysis. That is, S equals to 2 plus 3 into 4. These are the things. We just see. As per the parse tree, because based on these semantic rules, you know, based on this production rules and associated semantic rules, based on the production rules, we can find out ID plus ID star ID. Already we have seen this type of example. ID, this is ID plus ID star ID. Like this way, you can evaluate these things, and finally, each of the ID will get the value 2, 3, and 4. That is, E produces E plus T. Now, here actually E produces T. Here T produces T star F. Now T produces F and T produces F. Now we just see from the F. That means after F, you can put the integer literal value. That is, this is 2, this is 3, and this is 4. And to evaluate the translation rules, we can employ one depth first search traversal on the parse tree. This is possible only because syntax directed rules does not impose any specific order on evaluation until the child attributes are computed. before parents of the grammar having all the synthesized attributes. Again, I am repeating these things. To evaluate the translation rules, we can employ one depth first search. You just see here, depth first search has been, and finally we are getting the leaf node values. Depth first search traversal on the parse tree. This is possible only because syntax directed translation rules does not impose any specific order or evaluation until the child attributes are computed. This is the thing. Until the child attributes are computed before the parents of the grammar having all the synthesized attributes. Otherwise, we would have to figure out the best suited plan to traverse through the parse tree and evaluate all the attributes in one or more traversal. Let us see. We will move bottom up in the left to right fashion for computing the translation rules of our example. Here you just see that is 2 plus 3 into 4. This is the things. How can I get these things? Here f is getting the value 2. That means here actually just bottom up t value equals to f value equals to t value equals to f value equals to 2. This is for this level. This is also t value equals to f value equals to 3. Here this is f, that means you are getting, now you just level by level. Now here come here e value equals to 2, because here you are getting the e value equals to t value. It should be written in this way, e value assigns to t value, because you just see here e produces t, that means e value assigns to t value based on the production model 2. You are getting this e value equals to t value equals to 2. Here you just see you are getting t value equals to t value star f value, that is 12. Now you are getting using these production rules, that is first one, e value equals to e value plus t value. You are getting this value, e value equals to e value plus t value, that is 2 plus 12, that is 14. I think this is an easy example and you have understanding this. Is it clear? দেবারতী সাহা,
Yes, sir.
বুঝতে পারছিস এটা?
হ্যাঁ স্যার, হ্যাঁ স্যার।
Okay. You just see these diagrams shows how semantic analysis could happen. The flow of information happens bottom up, and all the child attributes are computed before the parents like this way. And right hand side nodes are sometimes annotated with subscript 1 to distinguish between the child and the parent. That is the additional information. Here you just see t. Basically, you just see here. Sometimes you can like this. The annotated means this may be t of the parent. T value of the, that is here t node is the parent, and here t node is the child. Like these things. You can, in this way, you can provide some suffix or like this thing. This is maybe t1, this may be t2, like these things, and that will just make you understandable more clearly that this is the parent, this is the child, like these things. Subscript. You can any subscript, or you can, this is t, this may be t1, like these things. Okay. Now you just see synthesized attributes are such attributes. Already we have seen, that is e produces e. Already we have seen this one, synthesized attributes. Also we have seen the inherited attributes. Synthesized attributes means value taking the value. That means any node is getting the value from its child, but in case of the inherited attributes, it can take the value from parent, or it can get the value from its siblings or child, like these things. Same thing, nothing new here. We have already seen here. You just see here. This is the example. Already I am telling you, this is basically annotated definition. Here this is E and this is E1. This E1 reflects, then this is a child, and this E reflect, this is the parent of that child. Like this E1, T1. Same thing. And that is the meaning of these things. This is a production, and this is corresponding its semantic actions. You just see, it's very easy. Check whether you are understanding or not. Same thing. Bottom up approach. Finally, we are getting the value E, and S produces E means you are printing the value of E dot value. And already we have seen this kind of examples. Here this is ID star ID plus ID, and you just see annotated parts. Annotated parts tree for the example, for the expression 4 into 5 plus 6. You just first draw the parts tree, and accordingly you will get the value, and finally you will be able to compute the values. And this is the explanation. Already I have explained these things, nothing new is there. Now this is basically for the synthesized attributes. Let us see the same example in defined ways. That means inherited attributes. Here actually we are getting these values. Inherited attributes, you just see some newer example. Basically concept is quite similar. Just as this is the inherited attributes, its pattern of the parts tree, annotated parts tree will be defined from the synthesized attributes. You just see here inherited attributes, that is, these are the attributes which derive their values from their parent or sibling nodes. That is, the value of the inherited attributes are computed from the value of the parent or sibling nodes. Already we have seen. Here basically B can take the value from A itself, C can take the value from B and A itself, and D can take the value from C, B and A itself. Because any siblings cannot take the value, or any child cannot take the value from its right sibling. There is some restriction, and here you just see C in equals to A dot in. That means if C is the integer, C integer value, it will take the value is equals to A integer value, and C type will be same equals to B type value. This is the fix. Now, computation of the inherited attributes, that is construction of the syntax directed translation using the semantic action, and the annotated parts tree is generated and attributed values are computed in the top-down method. Here you just see inherited attributes, as it may take the value of its parent node also, and that is why it will be a top-down approach. But in case of synthesized attributes, it will only take the value from its child node, and that is why it will be purely bottom-up. Here you just see S produces TL, that is L dot in equals to T type. T produces int, that is T dot type equals to integer. Now T produces float, that is T dot type equals to float. T dot type equals to double. And here you just see L comma ID, that is L dot in equals to L dot in. That means location where it will be there. And enter type ID dot entry comma L dot in. And here you just see finally L produces ID, that is ID entry. L dot in will come in the ID dot entry. Here you just see, assume the input string in ABC for computing the inherited attributes, and annotated parts tree for the string. You are getting these things. Int ABC. Finally, you are getting int ABC. That means int A comma C. This is for the string, and we are defining this for inherited attribute. That means you just see. First, we are using these things. that is value obtained from the parent A. Now L dot int equals to int, that means you are getting this is value A comma C and S finally. This is basically int, type in int A comma C. This is the thing. That means value obtained from the child node, this is from the parent node, this is from the semantic rules. T type, here you just see T produces int we are using, that is T dot type is basically integer. We are getting these things, and this is basically L dot int equals to integer, that means actually variable name we are getting value obtained from the parent, that is location here. A means the location, C is the location, and finally S basically that root will give you the declare this give declaration, that is int A comma B and A comma C. This is the case, and this is the annotated parse tree for the this input string int A comma C. Here you just see that is the value of the L nodes is obtained from the T type, which is basically lexical value associated with it, and the L node gives the type of the identifier, that is A and C, and computation of type is done in the top-down manner on the pre-order traversal, and using the function enter type. Here enter type, basically what you are getting the type of the identifiers, and A and C is inserted in the symbol table in the corresponding location, that is here entry of the symbol table id dot entry. Here C and A value will be inserted in the symbol table. Is it clear? We have seen the evaluation of an expression with the help of the synthesized attributes concept, and we have seen evaluation of the simple type declaration or variable declaration with the L attributed attributes. That is with the help of the inherited attributes concept. Do you have any questions regarding based on these things? I'm asking you whether you have understand or not. Yes or no?
Yes, sir. Yes, sir.
Yes, sir. Yes.
Yes, sir.
Okay, everything if you are understanding, then it is better. In the next day, if anybody take the class and I will be your student. जी ईसा क्लास ने भी पढ़ दिन.
हाँ, sir.
Okay. Anybody else want to take the class? Continue these things. At least one. Priyabato.
Nah, sir.
Okay. I think you have understand the concept of the semantic analysis as well as the syntax directed translation scheme. Okay.
Yes.
Next class I will take probably on Wednesday from 9 a.m. Okay. Thursday I will obviously take the class from 9 a.m. but Wednesday I will try to take the class from 9 a.m. Okay. And okay. In Thursday, I will continue the discussions on the predictive parsing and followed by LR0, SLR1, that is parsing portion. And if I take on class on Wednesday, then I will continue these things. Okay. This is the basic approaches we have got. That is, first one is the semantic analysis, followed by the syntax directed translation scheme. Okay. Okay. I think you have gone through the this. You don't have any doubt. I think I will send this copy to you. You just go through this document, and any doubts you can ask me. Okay.
Yes, sir.
Okay. Today I am stopping here, and Probably I will take the class. Most probably I will take the class on Wednesday. Okay.
Okay, sir.
See you.
Thank you, sir.